Sì. Bienvenido a todos. Estoy muy contento porque tengo la posibilidad que esté aquí y hago una charla sobre coches y faros más o menos, context-aware recommender systems using indoor locations. Al principio unas cosas sobre mí. Soy un profesor de informática de la Universidad de Ciencias Aplicadas en Hannover y hacemos una cooperación de un montón de años con el grupo de Sasha, Olga y Alberto. Y de momento tengo una estancia de investigación aquí, no tengo que dar clases en Alemania, no hay reuniones, es perfecto, tengo tiempo para leer y pensar un poco y a mí me gusta muchísimo. Y mis intereses, mi campo de investigación en Alemania son arquitecturas de software y sistemas inteligentes. Y en los últimos años trabajamos muchísimo en el campo de stream-based systems, sistemas con corrientes de datos, y utilizamos una tecnología que se llama complex event processing. La idea es que buscamos patrones en el corriente de datos y hay lenguajes específicos para definir estos patrones. Y hicimos unos proyectos para construir context-aware systems y con concept. Y los dominios de estos proyectos eran end-to-end systems, machine-to-machine communication. Trabajamos juntos con una empresa pequeña que está especializada en esta forma de sistemas. Y también hicimos un poco o bastante con RFID. Y también en este año o en el año pasado empezamos con utilizar icons. Y también quiero hablar sobre estas tecnologías un poquito. ¿Qué más? Son otros temas en que estoy interesado y quizás que hago ahora en el estancia de investigación, concept, tienes que definir reglas y patrones y es bastante difícil encontrar estas reglas y por eso vamos a empezar a utilizar métodos de data mining, machine learning para encontrar estas reglas. Vale, eso es. Y entonces voy a cambiar inglés. Yes, the outline of my talk. So, Sasha told me that you are actually also a little bit working in the field of developing systems in the emergency field. I don't know the title of the project, and so I thought might be interesting for you, and so I want to tell you something about our experience in this field, what our work, which is a little bit similar in this field. And so I have nearly two very small talks I will present today. And the first talk is about a context-aware recommender system we're also developing in a real world scenario, and that is more or less the work we did together with Ramon Hermoso. Ramon, I don't know if somebody of you knows him. He was a doctorado in the group of Sasha, and is now at the University of Zaragoza, and he stayed for a short stay in Hanover as well. And so one of the results I would present are out of this paper. And the other thing, I've very interested in counting people in rooms and these kind of things. So we had some experience about this, so it's not really research, but I want to tell you my point of view about these technologies. And actually, we are rather enthusiastic about IBM technology, and so I will tell you a little bit about this. So the experience is based on a master thesis, which Waldemar Zimmermann did, and then we had some student projects. We used some icons, and I can also tell you a little bit about the RFID experience we made in recent years. Okay, so that is the first part about the context-aware recommender system. If there are any questions or doubts, don't hesitate to ask me. I'm used to it from my students, and maybe it's a little bit more vivid if you ask directly. Okay, so that is the outline of my talk. And first of all, I want to think about what is CARS. CARS is an abbreviation which is not that familiar. It's context-aware recommender systems. Recommender systems are rather common, so everybody uses it, Netflix, Amazon, and so on. But we are interested in context-aware recommender systems. So context-aware recommender systems means that the recommender systems make use of the context. The context can be the situation of the user, such as age, gender, special interest. But the challenge is the real context is often frequently changing. So you have some kinds of user location or behavior which is continuously changing and which you have to take into account to make really good recommendations, individualized, personalized recommendations for a certain user. So my goal in this talk is I want to provide some kind of reference architecture for a CARS system which provides situational awareness. Okay, I will do it with a running example, and the running example is very common in computer science. It's the museum example, and so the idea to make clear what I'm talking about, the situation is there is a visitor in a museum, and he's standing in front of a big picture with Guernica and Reina Sofia, and the question which is arising, of course, is what would we recommend this user where to go next? Where should he go next to? And there might be different possibilities. Maybe he is interested in art of this time, so he would like to go to a Dali picture, but maybe he's not that interested in paintings, more in photography, and then she should go to a photograph of Robert Capa. What you want to recommend depends, of course, on many different things. So, first, what are the visitor's interests? Is he interested in photography? Then maybe he should go with Robert Capa. Or is he more interested in paintings? Then he should go to the Dali picture painting. Of course, there are other things which are really situation dependent. So it's the location of the visitor. If I know he's in front of the Guernica building, I don't want to send him to the Capa photographies, which are another floor and far away, and maybe it would be more interesting for him going to the Dali picture. And of course, another thing is, I'm also interested in room occupancies. So if a big crowd is standing in front of the Dalis, maybe I don't want to send him to this place. So that is only an example. There, of course, there are more aspects of situations which I should take into account. But that's a scenario we are looking at, and I try to develop now some kind of architecture to do it. Yes, please.
The last two are very related to our common project.
Yes, we also talked a little bit about how we can apply this situation onto the emergency thing. So it's very, very similar. And we really tried to develop a system. Actually, that's my last slide of this part. We tried to develop really a system in a museum in Hannover, and we're using different technologies. And so maybe it might be for you, I hope so. Okay, but I will start with a very general point of view on this architecture. So I try to give you some kind of reference architecture, which is decoupled from museums and domain or from other domains. And so what we did, in fact, we have two building blocks of the architecture. The first building block, there are the user agents. The user agents is just an app which is running on a smartphone. Each user has a smartphone, and so we assume that yes, we have a user agent running on each user's or visitor's smartphone, and this user agent knows about the user preferences. In my example, about art preferences, favorite artists, and so on. But it also knows about the user situation, so where is the user located, and maybe other things. That's the first building block. And the second building block is what we call the environmental manager. That is a server component running in a cloud or on a server. And this component has two types of knowledge. On the one hand, it has some structural knowledge about the museum and about art. So it knows what is art. I have some certain art styles like expressionism, photography, and so on. And I have some certain artists like Dali, Robert Capa, or Picasso, and that is a structural knowledge this environmental manager has. But on the other hand, it must also have some knowledge about the global situation. So how many people are in which room, because I don't want to send a visitor to a crowded room. During the next slide, I will look deeper and deeper on this structure, how we can fill these ideas with certain technologies or more conceptual things. So, that is a coarse-grained architecture. And first I will look onto the user agent. And I will talk about the responsibilities of the user. So, the main idea is that the user agent should provide the server component with the current situation of the user. That is the goal we want to achieve. Yeah?
For user agents, you consider that there is only one for each user?
Yes.
Because sometimes you are using different devices. For instance, I can be doing some activity here and at the same time with this, or maybe I am in a car and I have a smart car, and maybe it's not the same if I am just moving. You know that I am only moving with my phone, but if I am in my car and I go to the museum, I have to spend a part. There are many things.
Yes, I agree. You could use. We have simplified it. So what I'm talking about to make it simple to explain things. So we assume that you are in a museum and everybody has a smartphone. But of course,
only one user.
Yeah. But you could also, of course, assume that the user has different devices, which is changing. So he's in a car with a smart device in a car or a navigation system, which is capable of doing things. But you need software components running on the different devices. And of course, then you would have a user ID, and over the user ID, you could relate the different apps to a certain user. That would, of course, be possible. But we make it rather simple to figure out the main ID at this point. Okay. So that's the idea of the user. And so the first component, the first responsibility is triggering recommendation. And the idea of this is that we don't want to bother the user with a new recommendation every 1 minute or something like that. You also want the user to be provided by a new recommendation if he is in an appropriate mood. And we'll see later on some kind of rule, but an appropriate rule would be if a user is standing in front of Guernica and contemplating for 10 minutes, we don't want to disturb him with another recommendation. He should walk or whatever. And the recommendation triggering component allows us to specify some rules which say, now I'm interested in a new recommendation, and then the user agent is sending a message to the server and say, please trigger a new recommendation. I'm interested in a new recommendation. And of course, to make a personalized, individualized recommendation, the user agent has to send the context of the user, the position of the user, and all the other things which are known about the user. The second responsibility, the second big block, is a post-filtering component. And the post-filtering component is related to user privacy. Sometimes the user receives some recommendations of the server. There might be not only one recommendation, but many recommendations. And then the user should be possible to filter out that recommendation which is most appropriate to him or her. And maybe this criteria for filtering out these things, they should be private. I'll give you an example. Might be the user is afraid of heights, so he has some kind of vertigo. And so if the server is recommending him in the Reina Sofia, go up to the roof terrace, having a nice drink, maybe that's not a good idea for the user, and you don't want to follow this recommendation. But on the other hand, he doesn't want to reveal the server that he is afraid of going up to the roof terrace. So that's the second thing we have incorporated to it. Responsibilities of the server component, of the environmental manager. That, of course, is a component which really makes the recommendation. The user is in front of Guernica, and he will say, okay, next go to Robert Kaplan. What are the steps? On the one hand, first, the environmental manager has to evaluate the situations of all users. So maybe he has to figure out there are 3 users who are talking and standing in front of the museum. It should infer the global situation of the environment, how many people are in which room. And then if he knows rather precisely what the situation is of each user and also in the museum, he could make some recommendations. That's a very general follow of processing this data. We will see how it works in a few minutes. Next we have to look at is the kind of knowledge we need for such a system. So on the one hand, we have some structural knowledge. That is expert knowledge about the domain or knowledge which is rather stable, which does not change over the time. And on the one hand, we have researchable knowledge. We can define it using an ontology. There are some facts about the user preferences. The user likes Kandinsky, the user likes expressionism, whatever. But on the other hand, we have also facts about the museum. So, for instance, the museum has 100 rooms, and in room 3, Guernica is located. Furthermore, we have some conceptual knowledge that is about concepts, for instance, about art concepts. So maybe we have to know we have the concept modern art, and there are different art styles, expressionism, concept art, and so on. And we have to know a certain artist belongs to expressionism or to conceptual art. That is the first thing, structural knowledge. That is rather common in normal recommender systems. The other thing which we also need is situational knowledge. And situational knowledge is knowledge about the current state in the environment. This knowledge is continuously changing. What we do in our architecture, we will exploit live data, and this live data can only be provided by sensors. So we have more or less in the museum, we have 2 types of sensors we are considering. On the one hand, we are exploiting the sensors of the smartphone, figuring out if a user is moving, for instance. And on the other hand, we use these little icons which are placed in the museum and which we use to locate a certain user or to calculate the occupancy of a room or the number of people who are in the room. That's in the second part of my talk. I will talk a little bit more. Okay, each data this user agent is reading corresponds with a particular event. So the user is running or standing, or the user is in front of a beacon, which means he is in front of a certain painting. And of course, the change frequency is rather high. Okay, so that was a coarse-grained overview over the reference architecture. And now I would dive together with you a little bit more into the details and show you what kind of technologies you can use. And I give you examples of the system for the museum scenario, which makes it a little bit more concrete how everything works. Okay. So, and I will go through the components a little bit in more detail. And that is a user agent. The same details, these are a little bit more complicated. And that is the knowledge the user has. And that is the knowledge formulated in RDF using Turtle. And that is written rather easy. Certain user num1, he likes Kandinsky, he likes expressionism, he can speak Spanish, he is located in the entrance hall, and he has a new appointment at 12:30. And we see we have different types of knowledge. On the one hand, we have some preferences, so he is interested in Kandinsky and expressionism, and he can speak Spanish. On the other hand, we have also some situations. actually is in the entrance hall, and we have also some kind of plan. So we have a plan that you will have an appointment in the near future. Okay. That is a knowledge base. And the next step, that is a little bit more interesting maybe, we need some mechanism to be situation aware, and therefore we use some situational rules, and these rules are SEP rules, complex event processing rules. And that is also a rather simple example to transfer the idea. The smartphone is always trying to find, to read beacon signals. And what you see here is the following condition. The smartphone has read a beacon event. I call this beacon event B1. And then, that is a temporal operator. Then it is followed by a beacon event which we call B2. So first I read one beacon, and then I read another beacon, and the IDs of the beacons, they are different. So I'm running from one beacon to another beacon, and then I create a new event, that is here called change location event, and I put some data into the event. I'm moving from beacon B1 to beacon B2. So that is a very simple SEP rule. That is an artificial language. A real system is based on a real SEP engine. On a smartphone, you can, for instance, use Asper. That's what we always use on Android smartphones. And these Asper has a certain language where you can describe these kind of rules. A little bit more complicated than here, but this will show you how it works.
Arrow means immediately after.
Not immediately. There could be after. So if you look, every event has a timestamp, and the time of B1 is before B2. And there could be a lot of different events in between. In these event processing languages, there are also some language constructs where you can exclude that there is another event in between. That's also possible, but it's not meant here. So there could be any other events in between.
If it's not immediately after, there's a risk of triggering that rule several times. Because I was originally in B1, and then I moved to B2, and then I keep on B2, and then I keep on B2, maybe I moved to B3. Here, potentially, I may have triggered many times this condition, because it was true, unless it was immediately.
Yes, you are right. So you must make it a little bit more complicated. So what you also do normally is you have to put in some time windows. That's also what you can do. You can say that these events should be within a certain time window, so within 5 minutes.
I would just say right after. It's the only temporal operator that I can think can fit there without creating too much noise. Because if I am B1, and immediately after I am B2. Second thing, I don't need to verify this twice. And if I move, I keep on B2 after timestamp, it will not fulfill this condition. I know, well, it may be not the same context, but I'm thinking myself with rules and the temporal engine ordering.
Yeah, there's rules fusion. That is the same thing like Asper.
So I will have nightmares of situations like this one. That's one
But if you could use some kind of negation as failure. If B1 and not B1 after this event and then B2.
Yeah,
so take last B1 event.
There's a reason why rules provide you with operator right after.
Yeah, and Asper you have a lot, so that's.
I mean, you may have other events of other types between B1 and B2.
Yeah, what I mean is that temporal semantics are a subject in itself, and they are not so easily solved.
Yes, I agree. So there's some kind of simplification just to transport the idea, but you're right. But what Sasha said, you can say
can be done with negation as failure.
You have not, and then it would be not between that, not event B1, but of course that is. You're right. It's rather complicated. You think it's easy, but sometimes deriving these rules is complicated. I agree completely with you. So it's not that simple as it looks like. Okay. What you also have, you have some kind of gap between the different methodologies. So here you create a SAP event that is some kind of Java object, let's say, and here you have a knowledge base. And now I have a new location of the user, and this location has to be stored into the knowledge base. So you also have some kind of component. That's what is written down here. I will explain it in detail here in the talk, how you can map a complex event, processing event into the RDF knowledge base, because this is monotonous, so you have a location is only one, a user can only have one location. So what do you have to do if you have another location for the user? You have to delete the location, the former location, and put it into the, and modify it to the new location. So it's also some kind of thing what you have to keep in mind of that. Okay, so next thing is recommendation triggering. So I want to express that the user is only interested in a new recommendation if he is in a certain mood. That is also a rule which should give you some kind of idea, and that is some kind of description logic rule or general rules or something like that. So the idea is, when is the user or the visitor interested in a new recommendation? So he's interested if the last recommendation was already 15 minutes ago at least. He has changed the location. He was not in the museum shop, and he has not an upcoming appointment within the next 20 minutes. And then he should trigger a new recommendation. That's some kind of idea when you say I don't want to be bothered every 10 seconds with a new recommendation, only if this condition is fulfilled. Environment manager. So what is the environment manager doing? So first of all, it has the situation awareness component, which also is out of SAP rules. And here also a little bit simplified SAP rule, what tries to calculate the room occupancy of a certain room. So what is the environmental manager doing? He collects all the information of all the visitors, of all the smartphones, and he will get user position events. And these user vision presents, they are handled by a time spatial window. So I'm looking on a window of the last 5 minutes. I group the events by the rooms. I count all the events, and then I have the number of the people who are in a room, and then I create an appropriate event which carries this information. Okay. So the SAP rules provide the system with situation awareness. They are considering time, for instance, and they are capable of dealing with high frequency data, and they try to figure out how what is the situation in the museum in our scenario. The knowledge base. So the knowledge the environmental manager has is a little bit similar to that what the user knowledge base looked like. There is one difference. So here we have some very simple type of conceptual knowledge. I have the concept of artist, and a painter is a subclass of it, and I have some concept of modern art, and expressionism is some kind of subclass of it. And here we have some information on the one hand about the art. So Kandinsky is a painter, and he belongs to expressionism, and his painter is a picture, and the same for Macke. And we have also some information about the museum ontology. So I have some information about the ontology. So the picture, the writer, is hanging in room 30, and another picture is hanging in room 50. Okay, and the last thing, what is now about the recommendation. So we don't do cooperative filtering as in normal recommender systems. So we try to specify some semantic rules for recommendation, and that looks very complicated on the first point of view, but it's very simple. So that is a recommendation. If the user likes artist 1, maybe Kandinsky, and the style of artist 1 has a certain style, maybe, let's say expressionism, and we have another artist 2, let's say Macke, which has also the same style, expressionism. And we have of this second artist, Macke, a certain painting, and this painting is hanging in room 1, and the user is in room 1, and room 1 and room 2 are nearby. Then I recommend the user going to room 2 where the other building is staying. And we see we have a mixture in this rule of different type of information. So on the one hand, we make use of the art ontology, so we know about the styles of certain artists, and we make use of the museum ontology, so we know where certain paintings are hanging, and we make also use of the situational knowledge. We know that the user is located in room 1, and the combination of all this information gives us a recommendation where the user should go next. So that is more or less the approach we followed. Yeah.
How do you conclude that that's the route you need?
Sorry?
How do you conclude that that's the route you need?
Okay, so the idea is that we have some expert knowledge, and the expert is specifying this rule. The other thing, what we are also interested in, but that's future line of research, I will show it on the second picture. What we also try to do is, if we really track all the information about the user, then we can, of course, figure out correlations between user behavior. Let's say a user which is always hanging up in front of Guernica, he is also interested in, let's say, Dali, and then we can also, by this way, we can also, by machine learning methods, we can figure out these kind of correlations. That's the next step. So actually what we're doing is just an idea how to start, or how to, there are some kind of expert rules we have. We are trying to implement this system in a museum, and the curators in the museum, they have these kind of rules for us. So they have different types of people, children, adults, experts, and they say, oh, if somebody is staying there, he wants to go there, but there are also some certain types of interests they have.
What I think is that this is maybe not very good for scalability. When you have thousands of, in a big museum of paintings and things, sometimes instead of rules you use other kind of methods, data representation for doing recommendations. No?
Yes, you think that that is too slow because these general root type or so, that is not very.
When you go to a real museum and you start to put, maybe the thing, considering if you have hundreds of users at the same time and so on. So, what I would suggest, or is an idea, instead of to generalize more the architecture, to say, okay, instead of recommendation rule, you have a recommendation engine, and one way to implement that recommendation engine is if you work with rules in some cases, but in other cases, maybe you like to change the recommendation engine by another thing.
Yeah, I agree completely. Yeah.
More general, and okay, you say, okay, in some cases this is good because, in fact, as you mentioned, if you speak with the experts in the museum, they are going to provide you the knowledge in this way. So this is very straightforward. But sometimes you have to think of more complex recommendations.
I agree completely with you. So that's just one way to make it a different way around. The classical thing is collaborative filtering. But the problem with collaborative filtering is that you usually don't have the information in this kind of museum. So, but we can provide with this system, we know where does people stay, which are the ways of the people. So we hope that if we collect the information in the system where people stay and where people go, then we then can also use these kind of we can use collaborative filtering, for instance, to. The problem is in a museum, there is no information, so you can only ask the expert, and they say, okay, if people are going to that place, then maybe they are also interested in another search. So the expert recommendations, they are based on these kind of things. But maybe we are running into performance problems. We don't know. So we have started to implement it, but we haven't done it so far that it's really in a productive environment with many museum visitors. So, okay, so conclusion. We have provided a reference architecture for cars, and we've integrated different technologies, complex event processing for providing situation awareness, ontologies to describe structural domain knowledge, and semantic rules for deriving these individual recommendations. And the key features. In real time, using SAP, we derive the situation for a user and also in the museum. We have a high flexibility because it is rule-based, so we don't have a certain hard-coded approach, so we can change the rules rather easily. And we have also some mechanisms to support privacy of the user, that is a post-filtering step, that not everything is reviewed to the user, and if we don't want, so we also don't have to send all user positions to the server, just only those just only when the user is interested in a new recommendation, so then he has to review his position. Future lines of research, we are implementing it currently in this museum. It's a Landesmuseum in Hanover. It's not an art museum, which makes it a little bit more complicated. It's a museum of natural history, so it's rather impossible to make a real complete ontology for it. But nevertheless, so we talk with the curators there. They are interested in this kind of systems, and they also provide us with these expert rules. And that is what I've already explained. So we also try in the next step using some machine learning mechanisms for inferring automatically rules for recommending visitors in an individualized way where they should go next. Okay, yeah, more questions.
And this system, for counting the people in each room, you rely on users sending the messages, I mean.
Yes. So,
or it was just an example. You said each phone, the user.
You need that the user has the smartphone ready for digital, but some people is not using the smartphone.
Then he or she has bad luck. So the idea is that it should substitute the normal audio guides you have in the museum, and that there is of course a benefit. You must always provide some kind of benefit. So the user, they can say, I'm an adult and there are special contents for kids, or I'm an expert, or I'm a child. And so the idea is you go in front of a dinosaur skeleton, and then if you are a kid, then they show, I don't know what, a little movie. If you are an adult, they show you the place where it is found or give you more precise information. And so we hope that the users are motivated to install, or we could also provide the museum with a certain number of phones or tablets, and they could provide the users with these devices. That's the other possibility.
You know what my concern was, that the accuracy of the measure of number of people in each room. It depends.
It depends, of course. You are right.
It depends on the technology you have for identifying.
Sure. The prerequisite is that people have these smartphones, and of course you could also say 80% or 50% of the people have a smartphone, and then you can guess what is the occupancy in a certain room. There will always be the situation that somebody will not have it, and then you could also do it that way. That's true. Okay, more questions about this?
Yeah, could you discuss a bit more about the future wording of machine learning? Because I think that this a very interesting way of having those rules about filtering, recommendation, and so on emerging for the users maybe if you are going to measure with beacons, smartphones, and so on, you are going to gather plenty of data.
Yes, that is the idea, that you collect all the data and that you know exactly these informations, and using machine learning methods to figure out if a user is in front of Guernica, also what are the general rules the user is doing, what are the favorite rules. But that's we are just starting with it, and so that's my research topic here during my stay here, and I also have just started. So for more details, you have to ask me in a few months. I hope so.
Yeah, and the other question is, there is some museum where they are providing you for research this kind of data on user behavior just because of, well, just about occupancy or...
No, in that museum nobody has no idea about the real data. So the people working in the museums, they have some idea how the people behave, but if you ask different people, they also have different ideas about the user behavior. And to be honest, they also have some problems with collecting these kind of data, because if there's a curator of one part of the museum, he doesn't want to reveal that maybe his department is not that visited like another department of another curator. And so it's also a little bit difficult to convince them also really to measure this data, but I hope that will be possible for us. So, but that, of course, that provides us with much more possibilities, because instead of, let's say, Amazon, who knows what people are buying, nobody in the museum really knows how people really behave. That is only some kind of...
Are the guys don't record all some data on what I'm looking at?
Sorry?
Audio guides in museums, they do not record any data about your...
No, actually not. So
it's a shame.
Yes, so maybe they know how many people are in the museum in total, but they also have a free day like here in the museums, and then they are overrun with a lot of people, and during the other days it's rather empty. And maybe, I don't know, they have the number of tickets they sell, but they don't know about the sojourn times in the museum or these kind of things.
I guess with the audio guides, I mean, they kind of stick you to a certain way of going through the museum, right? So they are already numbered. So in this sense, it doesn't really allow you to explore different parts through the museum, but just go one. So it's,
yeah, sometimes they offer you the possibility of just introducing the numbers, so you are deciding your own path, and then you are...
yes. Sometimes that happens, but nevertheless, you have got the main path, and then some people get lost.
That's also
yeah, there's a problem. Okay. Yes, I'm running a little bit out of time, but I will run a little bit through the second part. That's not really research, but it's a little bit about our experiences with indoor navigation. Maybe you have some other experience and some other meanings about it. So I would talk maybe at least about the first two points, and how you can do indoor navigation or indoor location. And it's, as I've said, it's based on a master thesis and on one or two student projects we did. So how can we do indoor positioning, indoor location in buildings? Of course, GPS usually doesn't work in buildings, or at least it's not precise enough. So the first thing you can do is using Wi-Fi. And what you usually do, from my point of view, is that you have different Wi-Fi access points, and you try to measure the distance to the Wi-Fi access point. So I'm running with a mobile device in a room, and then I can measure the signal strengths. I reach different Wi-Fi access points, and then I can measure the signal strengths to this Wi-Fi access point. And what you will have to do is you try to estimate the distance to every Wi-Fi access point by using the signal strengths, and then you make some kind of quiliteration, and then you know, I have a slide later on, then you know where I am. Our experience with this is that it is very imprecise to do so, because the signal strength, it depends heavily on environmental conditions. You know, at home, your signal strength to your access point differs, and so it's nearly impossible to estimate the distance, and therefore rather precise location is nearly not possible. The problem is also that you have a rather high reach. So the Wi-Fi access point maybe from here is the next one maybe is 20 meters away, and it makes a difference if you estimate it's 20 meter or it's 30 meter, and that's also some kind of problem that large distances are rather difficult to estimate. The second thing, what we also used in some industrial projects, is using RFID. So you know it better than me that are passive tags, and you can use different frequency bands, which provides you with a different range. And the setup to do location could be that you would provide every person with a certain RFID tag. So the question is, how do they get the RFID tag? But maybe that's possible. And you have readers in the building, spread in the building, which read these signals. The big problem is that the readers are rather expensive. So these readers we know in the Corning Glass or wherever to prevent theory, they cost a few thousand euros, these big ones. And we also used in former times smaller ones, but they also cost you a few hundred euros. And it's nearly impossible to spread a lot of these RFID readers within the building. Then we have the same problem as before. You must have a high range technology, and then you must also estimate the distance using the signal strength, and that is very imprecise. And now we are rather happy. We had a lot of problems. It was really a mess for me. I didn't like this technology, RFID. It doesn't really work, as you know. You have a lot of problems with double reads and no reads and whatever.
But active RFID too?
Don't ask me details. I don't know it. You do it probably much better than I do. So we used it. The project is had happened a few years ago. It was, I don't know, 5 years ago or something like that. That's the technology we used. But I don't know if it's RFID too. And it was a UHF what we used, so it was a rather high.
I know they have a wider range, also longer. They have a battery.
Yeah. Okay. Yeah. Maybe. Yeah. You are the expert, so it's a little bit rare what I do. So Sasha asked me. So I'm not an expert in this technology. I'm a computer scientist, and we used it. So that's the only thing what I can tell you. So I'm not a technological expert. So maybe you can. And RFID from your point of view, it's now it's better to use, or?
I mean, they have a wider range than passive tags. Passive tags are bad. So 10 meters much, but with active ones, you have a quite wider range, like 30 meters or so. You can go in a room, just send a signal, and you get a response immediately, and you can cover the whole store and make the count of the items inside very quickly. So it's not that bad. Also, they are very expensive compared to passive tags.
Yeah, but the problem still remains is that you need a special reader, I guess, to read the signals, or it's not, or is there an app running on it?
Or a special reader. What do you call special?
Yeah, so we had to use we had to use a special antenna, for instance, to read the RFID signals, and so we had a smartphone, but with such an antenna in front of it to read things, and that was
for the process on passive tags, you already have equipped mobile phones with NFC antenna, so that works, but in very short range. If you want a wider range, maybe you need some additional hardware.
Okay, but maybe we have to give a talk about RFID, so I don't know. So actually we are very glad with Bluetooth and beacon technologies, so it came up 2-3 years ago, and we use it in several student projects, and their setup is that every person has a reader, because every smartphone, which is a little bit smaller, can read the signal, and you can put as many beacons as you want, more or less, into the building, because they are rather cheap. So this thing, I don't know, it costs you 10 euros or something like that, and you could build up a very dense network. So you could put in a room, you could simply put a lot of beacons if you like to sit in, and you can use them therefore with a very short reach. And that sounds like a disadvantage, but in fact it's an advantage, because if I use a very short reach, let's say 1 meter, then if I figure out that I'm in the range of 1 meter in front of this beacon, then I know exactly I'm in that position more or less, and so that's really, I don't have to estimate distances, and that is a big advantage you have, of course. Okay, so let's go very fast through it. So we have different sizes of beacons. That's the very smallest one I had so far. They have a battery. Here it's a very small battery inside, and of course then it will not send that long, but these bigger ones, they have normal batteries, and they should send in theory 1 or 2 years. We made the experience half a year is pretty fine, but that is what you can expect with these kind of beacons. They are using Bluetooth low energy, and they are rather cheap, and that are active sensors. They also, like this RFID2, they send just an ID, and it's the standard from Apple 2013. Apple didn't invent Bluetooth, of course. They just specified some kind of protocol, and it looks like that. Maybe what is interesting, you have a structured ID in beacons. So we have a proximity UID. Let's say that would stand for a certain company. Let's say Caught in Glass. A major ID that would stand for a certain building. Let's say Caught in Glass at Seoul. And a minor ID could be an ID for a certain department. Let's say it's a sport department in this building. And that is standing around. What might also be interesting is that Google also specified a similar standard just last year. It's called Eddystone. It's very similar, but the data format is a little different. The main difference is you have IDs, numbers. Google uses something which is a little bit like web URIs, and that makes it a little bit easier maybe developing web applications. Okay, that's the idea. You have your smartphone, you are in the range of iBeacon, and then the iBeacon is sending an UUID, you can read it, and this mechanism is integrated in the operating system, so in iOS and also in Android, if you have at least these rather recent technologies. And okay, so that is more or less the way it
One question about these iBeacons. Are they compatible with having wearables and still keeping the connection with them? Can I have my smartwatch and not having it disconnected whenever I enter in an iBeacon area?
Yeah, it's possible. No.
Mm-hmm. Yes, but you have a frequency.
You need a device which receives that signal, and this is Bluetooth 4.0.
Yeah,
Then it's working.
So you can search at the same time that you keep the connection?
Yeah, but the thing is this, without connection, they do almost nothing.
Exactly.
Then
So that's what I'm
the
saying.
interesting part is that the smartphone has connection to the other side. You have a server, you have the device. By now, the smartwatch is not fully compatible with that.
So we either keep the connection with the smartwatches or search for iBeacons.
What?
We either connect to the smartwatch or search for iBeacons. I cannot do both at the same time. If I
The
receive
smartphone,
a
you
call,
say?
yes, if I
No,
receive
no,
a
it's
call,
working both.
at the same time, if I receive a call, I can have my smartwatch ringing and at the same time telling me you are close to this iBeacon because I can do both things. So if I to the smartwatch and keep a channel open to search.
It's working.
But the beacons, they are also sending the signal in a certain frequency. You can configure the beacons with a web browser, and then you can say you can configure the strength of the signal, which can save battery life, and you can also configure the frequency with which the ID is sent in. So that is what you can do. Here are some different scenarios. So that's the scenario I used in the museum. So you have a beacon at a certain place, and if you are in front of it, then it knows I'm in front of the beacon, and you can read the beacon ID. Another funny thing, that's what Nivea did a few years ago. They had some kind of advertise campaign, and they distributed some kind of bracelets with a beacon inside in, and that was meant for putting it around the wrist of little children at the beach. And there was an app, if the children were going away, then the parents got an alert that they have to look for the children. So that's also possible. So those things are possible. Fixed beacons and beacons are moving. Everything is possible. And yeah, two different operating modes. So the first operating mode is monitoring. So it's just, you can say, scan beacon IDs, and then you get notification of all the beacons you get. And the second thing is ranging. That is, you estimate the proximity to an iBeacon, and in iOS you have different proximity values you can use. You can say, please alert me if I'm near of a certain beacon, and that means I only get an alert if I'm in the range of between nearer than 2 meters to the beacon. That's also what you can do. That's what we also use. Of course, you have the same problem as with every technology. So if there's something between the reader and the sender, then the signal is weakened. So that is always a problem. But if you have a range of only 2 meters, so it's not very, does not happen very often that somewhere is in between. That's what you assume. It's of course not always the case. And okay, yeah. Okay, I will skip a little bit through these slides. Everybody knew there are no students here, so that is pre-iteration, how you can make localization by estimating the distances. And what you also can do is some kind of fingerprinting. So we have here a floor of a building, and then you make a map with a certain point, and then you measure for this point all the signal strengths. And that is the offline mode. In an online phase, if somebody is going around, then you measure all the signal strengths. If you have the signal strengths, then you can derive I'm at that point. In our project, there are very contradictory meanings about if it's precise or not. One student said it's very precise, the other said it doesn't work. I don't know, to be honest, and we didn't use it. What we did is we used the proximity method. So we have this building, that's one floor of our building, and here there are these red dots, 10 beacons or something like that. And if you are running around with your mobile phone and you are in proximity mode, then you know I'm here. And there was one master. We didn't have that many buildings, every rectangle in the room, that many beacons. What we tried is some kind of interpolation. The master teaches you should make some indoor navigation, should interpolate where it is between these beacons. That was some kind of thesis we had. So that was the work of Rademacher Zimmermann, and he used the proximity, and then you knew you were in front of the beacon, and then he combined this with the smartphone sensor. So he tried to figure out how many steps the user did, and you also used the smartphone compass to derive the direction. It did work, but not really perfect. Here are some experimental results. The red line is really the way the user did, and the blue line is what the algorithm did. You see there are some jumps and things which couldn't work, so that was more or less the result of it. What was the setup? We had the beacons located in 2 meters high. There was also some difference where the beacon was placed. We used the proximity near 2 meters. And the problem was especially to estimate the direction using the compass. And future lines, or to improve it, what it didn't do was it didn't use really domain knowledge. So if you looked onto the picture, then the user is also going through walls and these kind of things. So what you of course had to take into account, you know it, that the user can't do certain ways, and then you could also correct these kind of things. So that would be one possibility to make it a little bit more precise. Okay, so that's it, very fast, but some of the impressions we had, and of course we use it also in the museum, and we made first try. Actually we are considering only 8 things in the museum which we configure with appropriate beacons, and it seems to work pretty fine. And so it's very cheap, it's easy for students to use, so we are rather glad with the technology. And that was it, 2 different talks, but thank you very much for your attention.